I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast. Hey Ben.
Hey Matt.
How you doing?
Great.
Great to hear it. So, I know that one of the things that you do when you're not writing tests is build cool things.
I try to.
And you've shared with us at work a video of one of the coolest things I've ever seen, which is tell us what you built.
An automated candy dispenser.
Why would you build such a thing? What on earth? What's the reason for such a thing?
Yeah, well, so I used to live in a neighborhood in Chicago. I still live in Chicago, but I live in a different neighborhood now. But I used to live in a neighborhood that was absolutely bonkers on Halloween.
Is bonkers a word that you, as an American, would use, or are you saying it because you've hung around with me too long?
No, I'm saying it because I'm looking at you, and I'm like, what's the right word here? When I look at Matt Godbolt, I think bonkers. So, no, it's because and it was like, full-size candy bars are like amateur hour in this neighborhood. If that's all you're doing, you're way behind the curve. So, and we knew this, and so like putting a bowl of candy out is not only an unacceptable solution if you want to go trick-or-treating with your kids, which we did. Both my wife and I wanted to go trick-or-treating with our kids. And this is when they were younger and much cuter. But and so, we wanted to go out. And so I can't just put a bowl of candy out there. What am I going to do? And I had been looking for an excuse to use one of the many Arduinos that I had just ordered, only to have them and just sort of assemble them and, possess them, collect them. Like, I should put these things to use. And so I built two versions of it. One version was a candy dispenser and this little like LED backlit, for some reason Super Mario themed game. The whole structure of it was like a carnival game. I called it Candy or Death, and it would alternate between two possible outcomes. There's a giant button, hit the button, and it like plays a song, and it like alternates between these things, Candy or Death.
Like the sort of the skill game on a fruit machine, where you have to kind of stop it on the right. Okay.
Yeah, except it there was no skill to it. It just almost like a roulette wheel in a way.
Oh, okay. So tick 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 tick.
Exactly, like that. And then it would always land on candy, and then it would dispense candy. And the idea behind this, right? Yes, and more on that later.
Okay.
But the idea behind this is that it was sort of like dinner and a show, because I needed to have a hopper that would hold so much candy, and I needed to know approximately, even with the ridiculous traffic, if there was like a line around the block of kids just hitting this button over and over and over again, how long do I have out trick-or-treating with my kids before I have to go back and refill the candy hopper?
Replenish
right?
the hopper, right, got it.
Exactly. And so it would take a minimum of, the first version I think was like a minimum of like 55 seconds, somewhere in there, to go through the whole thing and then eventually dispense the candy. And so, it wouldn't do it if it was in the middle of doing it. So you could just sit there and literally just hit the button over and over and over again, and it would have at least like an hour to an hour and 15 minutes worth of candy. So we could
because one piece of candy per minute.
Yeah.
Even if with someone just hammering the button, a couple of pieces of candy, and you just know, well, I can get 120, 150 pieces of candy into the dispenser. I'm good for an hour.
Yeah.
Got it.
Yeah. And the candy was kind of random, and that was sort of like, I think, part of the appeal. Is it almost always, I had it tweaked enough to where it would always give you at least some candy, but sometimes you get a bunch of candy, sometimes it would just be a little. And I thought that was just, I didn't want to fix that. That wasn't a bug for me, right? This is all part of the entertainment, right? But yeah, and so the first version was just sort of this backlit, I basically like took some, almost like, I forget this paper, but like almost like rice paper, and I built like a shadow box type thing with an LED in the back, and so it would sort of light up.
Got it.
And that was all controlled by the Arduino. And then the second version was that plus I replaced the LEDs with a actual TV screen controlled by a Raspberry Pi that played an animation. And this had like a skeleton hand that would spin around and music that would play.
That's pretty serious, an installation at that point, rather than like a microcontroller and a couple of LEDs and a servo. But we need to talk about how you actually built the thing, because that, to me, is like the really interesting part. But,
yeah, it was cool. So the candy dispenser itself ran on a Arduino, and the Arduino had a stepper motor shield that you could put on it. All this is on my, all the code for this is on my public GitHub, by the way, which is, Ben80. So github.com/Ben80. And it had this really cool stepper motor that I found, and the Arduino shield that went with it.
What is the stepper motor compared to like a regular motor? What is the difference?
Yeah, so it's basically just like a super powerful servo, right? So you can control with like a regular servo, usually, and also with a regular servo, usually there's like a range of motion that you're limited to, right? Sometimes they just keep going, but
a servo is like a thing where I can pick what orientation I would like it to be pointing at between, say, like 0 and 45 or something.
Yeah. It's like a motor that you can basically just rotate as much or as little as you want and to specific locations, right?
Okay, that's it.
Yeah.
Right.
So, like, if you've got, anybody that does anything in robotics, there's a lot of servos going on, right? Because you're just like, I'm going to rotate this motor 15 degrees to the left, and then whatever it's attached to also, hopefully
so
rotates.
Does the motor
degrees.
know which way it's facing? Or I guess in your case, it doesn't matter.
Yeah, in my case, it didn't matter. Basically, the thing that I figured out is I did a lot of testing with different kinds of candy and different...
Testing, you say?
Yeah, well, yeah, good point.
Always the testing with you. What is it?
Maybe, I mean, you want things to work, you got to test them. Maybe we'll call it experimentation. But
no, I like it. Yeah.
So I had this like cereal dispenser that I had found. There was like basically these rubber fan blades, and the cereal would sit in a hopper on the top, and you'd spin it. And you've maybe seen this in cafeterias or in other places where it's just they fill a big plastic hopper
like
full of
breakfast bowls.
Yeah, and then you just twist
one
it.
Or two portions.
Yeah, and so I had one of those, and I had hooked that up to, not directly, it was through a little belt pulley system. But I had hooked that up to the stepper motor, to get more gearing so that you get a little bit more torque, but also to elevate it up so that it could fall down and still hit the right spot in the window where the candy came out.
Got it.
But I had hooked that up to the stepper motor, and I had figured out that you can't, if you just turn it in one direction, it tends to jam. And so what it would do is it would turn a little bit in one direction, and then it would back off and turn in the other direction, and then it would back off and turn in the other direction, and it would basically alternate back and forth.
Jimmy itself, to get out if there was anything that was...
Yeah, and so it was much less likely to jam that way. But then that also depended on the kind of candy. So I tested lots of different kinds of candy. And
that's onerous testing.
Oh, man. Yes, I'd be ordering these 5-pound bags of candy off of Amazon, and I'd run it for like 2 hours, and it would jam and be like, well, this is useless. I can't use this candy for anything except
3.5 pounds of it
eating it all, which I definitely did. At a certain point, I was like, maybe I should just do Tootsie Rolls, because then I won't eat them.
Yeah, but then neither does anybody else.
Well, yeah, that's true. I did. So eventually I wound up with Jolly Ranchers. Jolly Ranchers were a good combination of hard candy, but with a wrapper that was like flexible enough to where you wouldn't get this sort of like, because I tried Starburst, and Starburst would like lock into position where the square blocks of the Starburst would just like form a wedge, and like no matter how hard you turned it, it just wouldn't give.
It's not going to move, right? Yeah, I got it. What an interesting thought. Yeah, so like the little tassels, not the tassels, like the plastic wrapper forms like a spring on either side.
Right.
And also a force that tends to, if you've ever tried to squish them, push it, like twist it away. So as they're kind of being squished together, they move around a lot. Yep. As opposed to, as you say, something like a Starburst, where essentially you're playing Tetris, except that the line does not disappear when you've got it complete. It just wedges your machine.
Exactly. Yep. That's exactly right. So yeah, so after some experimentation and testing with that, I had the stepper motor working. I had the candy that I wanted to use. And it was just, sitting down and writing like a little Arduino program to do this. And I love the Arduino IDE. It's super fun.
I was going to say, we should really talk about that, because if people I mean, obviously, there's physically building the stuff's cool and interesting. We should definitely get back and talk a little bit more about how you actually put it together. But the Arduino programming experience is pretty exciting, and you should tell us about it. What all does it look like? How do you do this?
Oh yeah, I mean, it's so fun to be able to just the IDE is really easy to use. You just download it, you plug in your Arduino via USB, and you can you can upload your code to the Arduino super fast. So you have a nice feedback cycle, and you can just be plugging components into the thing. If you've, I think the first one I did was one of the earlier models, so I didn't have it on a breadboard. I just had basically just wires running out of the thing. I actually forget how those connected, if there were like little female connectors that you could put those wires into. But it was really easy to plug stuff into. So you could plug in LEDs, plug in like other, like the button, I can control that. And you can, with a pretty fast turnaround time, experiment with it, right? Just try things out, right? And
you're like writing in what language are you writing all this stuff?
Well, it's like it's sort of a weird C++, the Arduino language, right? It's like, not nearly as fully featured, but you have certain C++ language elements that are there. And it's if you've written any programming language, it's not hard to figure out, right?
And presumably we're talking like a page or two of code. We're not talking like giant gobs of it, not multiple files, or are you? I mean, I know from my own like LED blinking.
I didn't split it into multiple files. Actually, the most complicated thing that I did with the first version was, the Mario Brothers flagpole fanfare?
Yeah.
That was the sound that it played when it dispensed the candy. And I had basically hand-coded that into the program as like frequencies.
Oh, yes.
And I had found a couple of places where it's like I thought I had the frequencies right. And my wife is very musically inclined. She played piano for years. She played French horn. She's a singer. And I played it for her the first time, and she was like, nah.
She recoiled in horror.
She's like, that note that's wrong. That's just, you're off. And I'm like, if you say so, I can't tell the difference.
This is,
But yeah, so that was honestly, most of the code in that file was taken up by that, just playing that fanfare.
And the rest of it was like turn motor on.
Yeah, it was like turn motor 180 degrees, wait 2 seconds, turn the motor 180 degrees the other direction, wait 2 seconds.
Got it.
Flash the lights, for the thing. But that was all that stuff was pretty straightforward.
That's awesome. And so the feedback cycle is really, really quick when it's like there, plugged in a USB board into your computer. And then presumably you've got wires dangling out, and you've got like something constructed nearby with a stepper motor that's kind of at least just turning so you can see how it's going to fit together, at least while you're developing it. Mm-hmm. How do you take that's sort of connected to a PC and then make it run elsewhere? It just seems like, hey, how do I install my software on it? How do I deploy it?
Right. Well, you screw it to a piece of wood. That's the that's the main thing that you do.
It persists, does it? Once you've copied the code onto that little Arduino, you don't have to flash RAM-y type thing, or that's just it. You kind of deploy it, and then you unplug it, and then you turn it off, and then put it somewhere else, and turn it back on again, and off it. That's so cool.
Yeah. All you got to do is turn it on, and it'll run. So it's really simple, and it's not that hard to write a little while loop to listen for inputs and wait for the state of a button or a pin to go high, and then do something. And so, it's a really simple environment to work in, and really rewarding, I think.
When something actually physically happens in the real world, there's
the
definitely a warm feeling you get from like, I'm controlling something in the real world. I mean,
feels like magic.
My kids do some like Lego Mindstorm stuff, and that's all like drag and drop things. But it's still really cool to move a motor around and kind of go, oh yeah, that's a real thing that happened because you typed some code in. But when you've actually built it yourself, it's got to be even better.
Mm-hmm. Yeah, it was super fun.
So you've got this motor that's powering this cereal dispenser, and you've kind of worked out the correct sequence of wiggles and the right candy to put into it, the right sweets to put into it for those listening in ENGB. It's also a bit late to say this now, but like for those who don't realize quite how big a deal Halloween is over here in the States, our international audience are like, what are they talking about? It's like, no, it really is crazy. You have to leave tons. We leave like a big bowl outside. We have the exact problem that you do, which is that we come back and within like 30 seconds, the bowl was empty because someone's just emptied the whole thing into their bag and got on. And then it's like, there's not really goodwill to the neighborhood kids if there isn't something for them. So this is obviously a very real problem and a real world problem that you're solving with this approach. But so anyway, you've built this thing. It's all connected together. Do you put it outside and do people steal it? I mean, that would be my concern in this kind of thing, is that someone would go, that cool,
was also my concern. I mean, we live in a fine neighborhood, but if you give teenage kids access to a giant hopper full of candy, they're going to take it, right? It's the same problem as the bowl. Yeah. So we had the fortune of our house having a window directly onto the front porch, right? It's like kind of to the side of the front door. And it was kind of a narrow window. It was only about 2 feet wide. And it had these child locks built into the window to where the window would only move up so far so that you could open the window and, be safe with kids. So they're not going to, like little kids, so they're not going to like push the window all the way open and fall out, right?
Got it.
And so I built it into that specific window with those child locks, right? So the way it would work is there was a faceplate with the button and the speaker in it. And then that was on top of a piece of MDF that held like the Arduino and the motor and the assembly for the hopper and all that stuff, and all the power circuit, all the power cables and everything was just sort of screwed into that piece of MDF. And so you could set it in the window and then close the window and lock it into place with the child locks.
I see.
And it would not only
partially closed, but you couldn't open it anymore after that.
Right,
from the inside,
right. It was the faceplate was the exact height of the gap that was created by the child locks.
Genius.
So you could basically lock the whole thing into place and have it be safe. I mean, you'd have to break the window with a hammer or something in order to get
at that point, right? You've gone from teenagers just robbing the candy because it's there on
you're
display
just breaking
to
into my house
actually
at that
breaking
point,
and entering.
Right,
Sort
of outside of the spirit of Halloween.
Yeah. Even over here.
Yeah. And then the cool thing is I could pull the shade down behind the window so that I would prevent any light from sort of leaking through. Because again, it's like I want it to be dark on the front porch, and I want the light from the candy dispenser to be the only thing that you really see, right?
Ghoulish, illuminated by the flashing red and green candy or death.
Right. Or the screen, in the second version, right?
In the second one, yeah. So we should... So you when I mentioned death before, you said there was a story. Is this the right time to tell that story?
Yeah, so the thing is that, my wife and I, it's not like we had another supply of Halloween candy, right? So when we came back from dispensing, or when we came back from going trick-or-treating, we would go in our house and I'd just leave the candy dispenser there. And this was great because you get to hear the reactions from all the people. We'd be just sitting in our living room.
That's so cool, yeah.
And people would come up and you'd get to hear their reactions. And by far, the thing that we heard most often was kids being disappointed that it didn't land on death. Right? They would just be like, they'd just do it over and over again, and they'd be like chanting, death, 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 and it would land on candy, and they go, oh, fine.
What is wrong with children these days?
Yeah. So, I don't know.
So they wanted death. Were you ever tempted to mete out, like 1 in 100 deaths, something like that?
I did have the idea of having it look like it like glitched out, and then switch to death, and then throw like a jump scare picture up on the screen, something that's not too terrifying, but something from like a horror movie that would just, just sort of like pop up on the screen and scare you. And what I wanted to do was put a webcam over the thing, so as soon as it did that, it would take a picture and then post it to a Twitter account, and then I could have the Candy or Death Twitter account with people going like, ah,
Which would last about 5 minutes before someone pointed out you probably shouldn't be doing that without consent and all those boring but very important things.
Again, Halloween. Actually, it's funny because like
all bets are off, right? You waived your rights when you walked up my front steps. A disclaimer at the foot of the stairs. Right?
It wouldn't be the craziest thing that has happened in the neighborhood on Halloween for sure, but not even by a long shot.
There's pretty macabre things around here. I've seen like bodies on spikes in the front garden. I'm like, this is not, that's not cool.
Yeah. But but I never did that. In fact, I don't own it anymore because when we sold our house, that was part of the deal for the house.
Oh my gosh!
I sold it with the house because it fits that one window. I'd have to completely rebuild it to do, and we don't even have a window in our new house that it would even. You don't have a window for this.
Oh, you don't. It wouldn't be. I was going to say you just live in a brick cube.
We're
done with looking at people.
It's actually all window. I live in a giant glass cube. It's like an Apple store.
Right. I mean, from the webcam, since you've moved, I haven't seen a new house. Like, there may well be no windows. I can't see any windows, so I assume it would make sense.
There's no windows here. But no, we couldn't have used it.
You sold it with your house because it doesn't fit the new house. And did you leave them with like an owner's manual? And
I made them an instructional video, actually.
That's so cool.
Yes. And actually the presentation. So you've seen my presentation that I did.
I have, which is what clued me into knowing about it. Yeah.
Yeah. I left that the reason I did it is because I was selling the house and I was like, oh, I'm not going to have this anymore. And also the new owners need to know how to use it. So I'm going to do a talk on it. And then I'm going to leave them the link to that talk and some video so they can see some other things.
So is there a YouTube link actually in the closing documents for your house? That would be the legal documentation that says
sign the rights of the video over to them as well.
The seller represents that this is how the candy dispenser works. And
it's part of the inspector was like, this candy dispenser's not up to code. There's
but did you show him the tests? Did you write any tests?
Did I write tests? So in the Arduino IDE, I had a test mode, right? So if you turn the thing off and turned it on and you held down the button, and this made me think when I was making this, is like, surely there are like old school coin-op video games and vending machines and things where if you turn the thing off and you enter in the right code in the vending machine, all the candy comes out, like all the food in the vending machine comes out. Yeah. That has to exist. And doing this sort of reinforced that for me of like, if you turned it off and then turned it back on and you held down the button so that the button was pushed when it started up, it would run a diagnostic. And it was basically just me with a bunch of asserts checking a couple of the functions that I had written. And then it would go into this like auto dispensing loop that I could use for stress testing, right? So if I was testing out a new kind of candy, I could just do this and leave it for 3 hours or 2 hours or whatever and come back. And if it had jammed, then, okay, that candy was no good.
Do you get feedback if it does jam? Is there like a readout from the motor that says,
no, it doesn't.
There's going to be a fire soon because the motor. Oh, okay.
Yeah.
You're going to get like clicking horrible thing.
Actually, what would happen is the belt would slip. The motor was powerful enough, but the teeth on the timing belt would just slip.
Got it.
Yeah.
And so we haven't talked about the second version very much. So that was more complicated than just an Arduino and some lights and a while loop. It had a Raspberry Pi, did you say, and a screen, a TV screen.
Yeah. So the way I did this,
tell us.
The way I did this was I hooked up a Raspberry Pi to the Arduino over the same USB cable that you use to program it, right? And you can just talk over that serial connection and send bytes in both directions, right?
Oh, neat.
Yeah, and then on the Raspberry Pi side, I just, opened up a serial connection to that device and read the bytes that it was sending. And all I really needed was just the signal for when to play the animation, right? So I don't know what message I sent. It was probably just some like hello world string or whatever.
So the Arduino was the driver, effectively. It was in control of the whole show here, and it was using the Raspberry Pi, a full Unix operating system on a small ARM, many hundreds of megahertz ARM chip, as essentially a glorified graphics card.
Yes.
On a wire.
Yes.
Over
That's
serial.
Exactly right. That's exactly right. And so when it got the signal, it would play the animation. I actually did it all in Chrome with SVG. So it was like serving up the thing running on the Raspberry Pi was listening to the serial port and serving up a very, very tiny web app that would play this animation and play the music, right? And it would just do that in response to getting the signal over the...
So it was a dynamic web page that was showing the content.
Yeah.
That is, I mean, people talk about being a full stack developer, But until until you were writing an Arduino like low level stepper motor driver talking over serial to a web browser, and that's a whole product, then you're not full stack.
Yeah, right.
I don't know gatekeep what full stack is, not at all. Like it's that's just amazing to sort of have a fun project that touches so many different areas of problem solving and computing.
Yeah,
and
it's like when you type something in your web browser, what happens? When you push the button on this thing, what happens? Well, first the Arduino sees that the pin has gone high, and then it starts playing a song.
Did you use? I'm going to have to bring up my favorite thing to talk about, which is when you're down at the low levels like this, and you're looking for edge events like a button being pressed. You mentioned earlier you had a while loop, but did you use an interrupt? Tell me you used an interrupt and you just went to low power mode, and you're so disappointing. You missed a golden opportunity.
Can you even do that on an Arduino?
Yeah. There's some of the sort of like Pigeon C++ extension-y type things that they've got allow you to tag stuff as interrupt handlers and set them as interrupt handlers and stuff, so you can do some of that nonsense.
Did not know that.
You didn't need to do it, so you didn't, because it turns out that if you're not battery constrained or anything like that, sitting in a tight loop going while read this memory address is not equal to 0, sit in a tight loop
works just fine.
It's just fine. Yeah, but no, I just an opportunity to kind of get that end as well. There's just another rung down.
Yeah. Well, yeah. If I was running this thing off a battery, that would have been a whole other deal, for sure.
A whole other world of consideration. So, the obvious next question is, what are you going to do in your new house?
What am I going to do in the new house? The thing I built in my new house is, I built a golf simulator because I like to play golf.
Oh, well, this has taken an unexpected turn.
But that's almost like a whole show unto itself. Because, man, once you have simulator data that you can export and analyze, there's a whole other level of nerdery that happens. That is.
Oh my gosh.
Yeah, that is definitely a whole other episode.
That's another talk. Okay.
Yeah.
All right. But you definitely piqued my interest there. I'd love to hear about what the heck that is. But no plans then for any Halloween magic or for resurrecting something similar to it. Is that you've kind of done that? You've got the T-shirt. The kids are more grown up now, baby.
Yeah, our kids themselves. They
when
don't
you're
really...
allowed out of the house at all, obviously.
Yeah, right. When there isn't a pandemic going on. They can go trick or treating by themselves now. Honestly, if they want to. And I think they did last year or the year before. It was snowing, I remember. But yeah, it's sort of been there, done that.
You've got the T-shirt. You've had your fun, and now you've moved on to more things that actually impact you directly. Like I know how much golf means to you, so a golf simulator is more in keeping with stuff that you're interested in, rather than just a service to the neighborhood kids.
Yeah.
Cool. Well, I guess we'll talk about that another time.
Yeah.
And I'm disappointed that you didn't have an actual test framework for this, and you just have to hold down a button. But
I did write tests for the web app that lived on the Raspberry Pi. That had tests. But the Arduino code only had the diagnostic mode.
Although, in fairness, writing tests for web pages is about as difficult as writing tests for embedded systems, right? It's still awkward to do it most of the time.
Easier.
Is it?
Much easier. Oh, it's so much easier.
We should not go back to testing just yet, but at some point you're going to have to explain to me how to write decent web tests, because I can't. But that's another topic. So
that's another talk. Yeah. Do you want to talk a little bit about your picture frame that you've been working on?
Oh, I guess we could. Yeah.
I would like to hear a little bit more about that.
So, yeah, I saw a YouTube video from an acquaintance of mine who had made a kind of joke present for his mum, where he built a picture frame into with an e-ink paper into like a little photo frame, like a regular photo frame that you'd put a normal photo in, and gave it to his mum as a present. But unbeknownst to her, every day or every couple of days, the picture would change overnight. And he was betting how long it would take her to notice. And unfortunately, I think she realized something was up because it didn't look quite right, and it was. She knows her son, so it was under intense scrutiny. But anyway, it was inspirational to me, and I thought I've just been lucky enough to be sent a Raspberry Pi Zero, which is a Raspberry Pi that doesn't run Unix, unlike all the other ones. It's just a chip on a board, and a very low power chip at that. And I thought, hey, why don't I give this a go? And I'm going to try and make it run off a battery. Because Charles's setup was on a Arduino, which I've also got an Arduino knocking around somewhere as well. They're great fun, and the IDE is just brilliant. Like we were saying before, I was just interested in using the Raspberry Pi, Pico. If I said Zero before, I meant Pico. I forgot what I said. It's late in the day now. But yeah, Raspberry Pi Pico. It's just nothing to it, just a little board. And so I picked up the same e-ink screen, and this is a color e-ink screen. So it's got 7 colors, which is a weird number of colors to have, as you can probably imagine. 8 would make more sense. Mm-hmm. And so it's 4 bits per pixel. Bizarrely, the internals of this screen are very much like an actual CRT display. Like you have to set up timings and how many pixels across it is, how many pixels down it is, how quickly the vertical refresh happens. But it's clearly not updating 60 times a second or 50 times a second, right? It's just that seems to be the communication between the RAM on the board and the actual physical screen itself. Like this is a well-established way of addressing each pixel. The best way of doing it is to sort of stream out the colors one after another to some circuitry that can then make sure the right color gets to the right pixel. That said, though, the way that it works is that you kind of populate this memory and then you kind of say go, and then it starts doing the kind of Kindle thing, if you know what I mean. If you've got a Kindle that's got an e-ink display, it kind of flashes on and off and kind of has a real laborious time of it as it's kind of like reset the e-ink. Except it takes even longer because it's got multiple color cells to do it. And it seems to be there are just different cells with like colored lenticles over the top of them to give you the 7 different colors. And the 7 colors are like red, green, blue, yellow, browny, orange. That's 5. There's another, but to be honest, most of them look brownish, right? It's not very good. And so it's 600 by 448. So it's quite high resolution. So some dithering gets you some way. But all the algorithms I've looked at for dithering, the standard ones, Floyd Steinberg error diffusion is the one that I picked. They work really well with luminance from a screen, but they don't seem to work as well with essentially a paper medium, which is essentially subtractive. And I'm trying to wonder if there's some almost like newspaper style half toning that used to happen, like on printers versus the kind of thing you do for a screen that I might look at. But anyway, the code, it runs on the little Zero. It talks over SPI, which is a standard serial protocol to the display. I've got a little direction sensor on there as well, which can tell whether it's up.
Oh, that's neat.
So that, if you can pick up the picture frame and put it on its side, it'll only show portrait things, and you put it back in, it'll show landscape photos. And so there I use an interrupt handler, so I can go into low power mode. You see, I get it out in the end. We'll talk about interrupts, so that it can go into low power mode between essentially what would be like a sleep for, at the moment I've got it like 5 minutes, just because I can see it go. It's been a lot of fun. I plan on putting the whole thing, at the moment it's on my shelf in the other room, but it's like, if you to look at it any further than any closer than like a couple of feet, you'll notice that behind it is a ton of breadboard and wires and batteries and things, so it's not very good. I'd like to get it to the stage where I can get a breadboard, an actual copper track breadboard, old school, not like the pushy pin ones, but and solder onto it and get that actually sort of fabbed enough to then get everything into the little clip frame that I've got for it, because the whole thing is only like a half a centimeter thick, which is I don't know, some 29/64 of an inch or something. I don't know. You Americans and your crazy sense, but 5 mil kind of thick thing. But it's been an interesting experience. The Raspberry Pi SDK, the Zero. I keep saying Zero. The Pico SDK is shipped as like a GitHub project that you just git clone and then you kind of just make it in, and it's all written in C and C++. They've done a really good job of documenting it. You kind of link the whole operating system, such as it is, it's just support libraries into your executable, and because it's you have like a sibling directory with all the code, and it builds it as source. So you change your compiler, and it's going to pick up all of the whole operating system, and you just get like a single image to deploy to the app to the device. And the way you deploy is when you turn it on, just like you were describing before. There is one button on the top of the thing. If you hold down that button when it's powered on, it goes into like a receive mode. And there it looks like it's a USB thumb drive.
Oh, neat.
And you copy a single file onto it, and as soon as you finish copying that single file into it, that's the image it's going to run from then on. It just flashes that image, and now it's that. So I've got like a little watch loop. We've talked about the watch sort of targets before now, which look for the USB drive to appear, and when it does, it copies the current version in, and then it waits for it, and then it gets the serial port debug interface up and just waits on. So I've got a little like REPL style thing where I can just hit build. The only annoying thing is I have to like press the button, and until I wired in a reset button myself as well, it meant that I actually had to unplug and plug the whole thing back in again, which was a pain in the proverbials. But you can get an actual debug header for it, and then actually debug it. But the easiest and best way to connect to the little 3-pin debug system that it has is to use another Raspberry Pi Zero as like the adapter. And these things are $3.99 each. It's just silly. So I just ordered 20 of them because I'm going to find it. This is exactly like you and your Arduinos on the shelves.
That's why I have half a dozen BBC micro boards sitting on my shelf, right?
Exactly right.
Yep.
So yeah, these cool things are you use them as the adapter, the debug adapter, and so unfortunately because everyone has rushed off to buy them, they're out of stock everywhere. So I'm waiting for more to come through, which is why I've sort of shelved it for now until I can debug it properly and get my few other bits and pieces through. But it's just great fun. It's great fun to have something, and I'm hoping that it's inspirational for the kids to see that with relatively straightforward code. I mean, again, at the moment, everything that I've done in my code, with the exception of the gzip library, which I've kind of got hidden away somewhere else to compress the images and put them on into the image itself, everything fits into a single screen.
Yeah.
Or so. And that includes me going slightly crazy and wrapping the screen driver that I had written in nice C++ 17 objects that are all, all the nice things, all the nice trimmings. So, which means it's more than one page of code. It's one file. I said it was one screen. I mean, it's one file. It's about 2 screens worth of code, in as much as a screen is a decent measurement of code. But it's not much. It's just fun. And exactly as you say, like, hey, when you are just doing a relatively straightforward single thing, you don't need very much code.
Yeah.
Like while, I go, hey, sleep in low power mode for 5 minutes. Cool. All right. Now send this byte to the over the SPI to the display driver, which wakes it back up again from its slumber that I put it in, and now stream 600 times 448 divided by 2, because there's 4 bits per pixel, colors from an array that I just unzipped. Okay, and then let's sleep again for a bit. Give it the magic command to say and go, and now watch it do its screen changing, and I'm going back to sleep again. But it's so cool. Yeah. It's so cool. If you don't mind a very dull, slightly brown image of anything you wanted to put on it. So my original hope was to give this to my wife as a Valentine's present. Oh,
yeah.
And I failed to deliver it to her in time.
Next Valentine's.
But I told her about it, and so I got almost as many kind of romance reward points for the idea of it than the actual implementation, because I don't know how excited she would be really about a muddy pictures of us.
Well, they say that it is the thought that counts.
They do say that it's the thought that counts. And this is also not the first time that she's had to put up with devices that I've wanted to make as either gifts for her or for me, because I think for my 30th birthday, I said to her, rather than getting anything, getting me anything, I should say, I was going to buy a bunch of components and build my own MP3 playing system that could plug into my amp.
What year was
I still
this?
have the parts. 15 years ago. I got it working, but ultimately, I ended up buying like a squeeze box, which was this commercial offering that did the same thing. You know, this is like pre-Sonos, that kind of stuff. Where I had a server that was chock full of all my MP3s, and I couldn't play it on my nice hi-fi because there wasn't a way of connecting the two. And so I thought, well, I'll make one.
Do you see? I don't know if you can see this in the webcam. Do you see the sort of steel and plastic contraption sitting on the top of my
on the top shelf? I have many times wanted to ask you what that is.
That is a computer that I installed into my Honda Civic in around 2002 to play MP3s because you couldn't buy an MP3 player at the time. And so that one is voice controlled. There's a little lapel mic that I wired through the car up to the driver's seat. And there was a push-to-talk button, and you would push it, and it would use the Windows voice-to-text API. We should talk sometime about the trials of trying to get a computer to shut down reliably and not overheat in Texas.
In a
car, if it's a Windows machine. But
wow.
But you could push a button, and you could say the name of a song, album, or playlist, and it would play that song, album, or playlist.
That's amazing.
Oh my God.
That's so cool. When was that? I mean, obviously this was when you were in Texas, so that's
it was immediately after I graduated school, and I'm like, I have money. I can spend this money on whatever I want. I'm going to build a computer into my car, right?
That's so cool.
That was my geek project. Oh my God. MP3 players, man.
I mean, if we needed more reasons to say that we are similar. We took a different fork at the beginning, but we have remarkably consistently done similar things. About 15 years ago, MP3s.
Yeah,
that's cool. Well, there's lots more to talk about there, and I definitely want to hear about your golf machine at some point, and maybe we should record something and put it on a YouTube for people when we talk about that.
We could do that.
Then we can critique your golf swing as well.
We could have, oh boy, critique golf. That'd be another. That's embarrassing. Yeah, we we should do like a YouTube channel or something and do some of these. We're talking about these presentations that we've given, but
we've given before. We could at least collect them in a playlist. We've got a few things that we've talked about.
That might be a good idea.
Cool, my friend.
Yeah.
Well, let's think about that some more when we're not recording for a podcast so that we can actually talk about it. Rather than
good call.
Sort of make ourselves promises that we won't be able to keep.
Right.
And we've got tons more to talk about. So I guess until next time.
Yeah, sounds good.
All right, mate. Later. You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcript and notes at twoscomplement.org. Contact us on Twitter at 2CP, that's at TWOSCP. Theme music by Inverse Phase, inversephase.com.